Hello, Physics 20s. I wanted to share a quick insight on Newton's third law in addition to all the other information you've already seen. And it has to do with, I'm just going to use question number 10 on these series of questions. As you know, Newton, or as you're remembering, maybe Newton's third law states that every action has an equal and opposite reaction. A classic question would be having three boxes together, as it says in question number 10. And it says that there's an applied force acting on box X that causes all of the boxes to accelerate. This is a net acceleration, and you'll see that in other questions. You need to find, if it doesn't give it to you, you need to find what the net acceleration is for all of the masses in the system. So I may back up and do that in just a second here. So the interaction that we're looking at here, anytime you have a third law scenario, I like to draw a dotted line that shows where the interaction is happening. Sorry, that's not a very good dotted line, but box Y is pushing on box Z. And so Z is going to, Z will react to that by pushing with a force that's equal but in the opposite direction. And so if we look at just box Z, some students will just separate box Z. And if you just look at Z, Z will be experiencing a force from Y. So we would call that the force of Y on Z. Okay, the force of Y on Z. Now, if we can just figure out what that force is, then due to Newton's third law, Z will push back with an equal and opposite force. But if we're drawing a free body diagram, I don't do this. I don't draw a force arrow like that, because box Z is only experiencing one force, but it's just that Z will push back with an equal and opposite force. So what we look at is we say, well, then how much force does it take to accelerate just block Z, which has a 3 kilogram mass? How much force would it take to accelerate that at 3 meters per second squared? Well, very quickly here, you can maybe see this math. We would do a force calculation, and we'd have 3 kilograms, a 3 kilogram mass times 3 meters per second squared, and we get 9 newtons. Okay, so that this force, and this is really the force of Y on Z. I know I'm just going to keep track of that, sorry. Y on Z. So it means then that block Y will push on block Z with 9 newtons of force to the east. So if I'm trying to figure out how hard does X push, or sorry, does Z push back, then Z will push back in the equal and opposite direction. So the correct answer here should be 9 newtons to the west. I could easily ask this question another way. I'm just going to actually clear this all off, because we could very easily ask a question where I want you to tell me how much force there is between X and Y this time. Okay, so if my interaction is between X and Y, which is not what this question is, now I know they're all of the masses are still accelerating at 3 meters per second squared, but the amount of force that Y experiences, Y is going to experience a force, we could call this the force of X on Y now. But X has to push hard enough to move all 8 kilograms of mass now, because there's more mass downstream, if that makes sense. So if we stuck a little force meter, say right in here, if we stuck a little force meter right between X and Y, right in that area, then that would read a different amount of force than the force between Y and Z, because block X has to push 8 kilograms. So what we would do to figure out the force of X on Y would be very similar. We would just say F is equal to the mass times the acceleration. In this case, the mass, though, is going to be 8 kilograms, okay? Because there's 8 kilograms of mass that's being pushed downstream. So now I would multiply that by 3, Because remember, all the masses are moving together. It's a frictionless surface, and so I would get a force of 24 newtons this time. But again, the force of X on Y would be 24 newtons to the east. And so if I want the force of, we could say if they asked for the force of Y on X, that would be the reaction force, right? So there's an action force and a reaction force. The force of Y on X would be 24 newtons to the west. Okay, so hopefully that's helpful as you keep going on through these questions. Very good.